Hey buddy, buckle up because we're about to dive into something that's straight out of a sci-fi thriller, but it's real science shaking up how we see our planet's wild history. Forget everything you thought you knew about volcanoes. We're unveiling a radical theory that connects cosmic collisions to Earth's fiery heart. What if a celestial punch from the distant past is still echoing today, igniting eruptions that shaped our world? Prepare to see our planet's history from a whole new, extraterrestrial perspective. Picture this: a massive meteor hurtling through space, slamming into Earth with the force of 1 billion atomic bombs. The ground shatters, dust blots out the sun, and life hangs by a thread. But wait, what if that same smash doesn't just end eras, but kickstarts others? What if it rattles the planet so hard that volcanoes on the far side wake up and spew lava for millennia? That's the mind-bending hypothesis we're unpacking today. Ancient meteor impacts triggering volcanic activity. It's not just some fringe idea. It's got geologists, paleontologists, and astronomers buzzing with evidence from craters, lava flows, and seismic simulations. I'm excited to walk you through this like we're chatting over coffee, because honestly, this stuff keeps me up at night wondering about the cosmic chaos that built the world we know. Let's start with the basics to set the stage, but I promise we'll get to the juicy cosmic volcanic hookup soon. You know how volcanoes work, right? In school, they taught us it's all about plate tectonics, those massive slabs of Earth's crust grinding against each other, diving under one another, or pulling apart. When plates subduct, they drag water and rock down into the mantle, melting stuff and sending magma bubbling up through volcanoes like those in the Ring of Fire. Then there are hotspots, like Hawaii or Yellowstone, fueled by mantle plumes, hot, rising columns of rock from deep in the earth, core mantle boundary that punch through the crust like a blowtorch. These plumes create chains of volcanoes as plates slide over them. It's elegant, it's proven, and it explains most of the fiery action on our planet. But here's where it gets intriguing. What if some of those massive volcanic outpourings, the ones that blanketed continents in lava and choked the skies, weren't just internal Earth drama? What if a space rock's wallop from above cranked up the volume? Enter the star of this show, the Chicxulub impact. That infamous asteroid smashed 66 million years ago off Mexico's Yucatan Peninsula. You know it as the Dino Killer, the event that wiped out 75% of life on Earth, including those majestic T-Rexes. But did it also flip the switch on one of the biggest volcanic binges in history, the Deccan Traps in India? The Deccan Traps aren't your average volcanoes. They're flood basalts, a type of eruption that pours out rivers of lava over vast areas, stacking up like a giant pancake pile. We're talking over 1 million cubic kilometers of rock, enough to bury the entire United States under 600 feet of basalt. These eruptions happened right around the same time as the Chicxulub hit, at the Cretaceous-Paleogene, KP, boundary. Coincidence? Maybe not. Scientists have been debating this for decades, and the evidence is piling up on both sides. Back in 2015, a team led by Paul Wren at Berkeley proposed that the impact as shockwaves could have supercharged the Deccan eruptions. Imagine the asteroid, about 10 kilometers wide, hitting Earth at 20 kilometers per second. The energy release is insane, equivalent to all the world's nukes going off at once, times 1,000. That punch sends seismic waves rippling through the planet like a gong. These waves focus and amplify as they travel, especially toward the antipode, the point directly opposite on the globe. For Chicxulub, that antipode was roughly near the Deccan region in India, give or take a few thousand kilometers, close enough in planetary terms. The theory goes that this focused energy rattled the mantle, cracking open pathways for magma that was already simmering due to a mantle plume. Boom! Eruptions intensify, spewing sulfur dioxide and carbon dioxide that mess with the climate, acidify oceans, and help seal the dinosaurs' fate. But hold on, it's not a slam dunk. Dating these events is tricky because lava flows erode and overlap, and the impact left a precise iridium layer in rocks worldwide as a timestamp. Recent high-precision dating, using uranium lead methods on zircon crystals from the Deccan lavas, shows eruptions started maybe 100,000 years before the impact and continued after. A 2019 study in Science nailed down 4 major pulses of Deccan volcanism, with the biggest one kicking off right around the impact. Researchers like Mark Richards argue the asteroid's jolt caused a transient increase in permeability in the magma system, basically unclogging the pipes and letting lava flow freer. Seismic modeling supports this. The impact could generate energy densities of 0.11.0 jm3 throughout the mantle, enough to trigger quakes up to magnitude 9 or 10, way bigger than anything we've seen. Skeptics point out the antipode isn't exact. Chicxulub's opposite is in the Indian Ocean, not smack in the Deccan. Plus, the Deccan plume was already active, so maybe the impact just coincided without causing much. A Princeton team in 2009 argued volcanism alone could explain the extinction, with gas releases causing global cooling and warming swings. But a 2024 study pushed back, saying while volcanoes caused climate havoc pre-impact, the asteroid delivered the knockout punch. It's like a tag-team extinction. Volcanoes set the stage, Meteor finishes the job, maybe even amping up the lava flow. This isn't just about dinosaurs, it's a pattern. Take the Sudbury impact in Canada 1.85 billion years ago. One of the largest craters on Earth, it smashed into the crust and, according to a 2017 study, triggered long-term volcanic activity that lasted up to 1 million years. The impact melted rock, disrupted the mantle, and created conditions for eruptions far beyond the crater. Researchers found geochemical signatures linking the impact melt to later volcanics, suggesting the collision decompressed the mantle, letting hot rock rise and melt. Similarly, the Permian-Triassic extinction 252 million years ago, the worst ever, wiping out 90% of species, coincides with the Siberian Traps flood basalts. Some hypothesize a hidden impact antipodal to Siberia sparked it, though no crater's been found yet, maybe buried or eroded. Seismic focusing could explain why these massive igneous provinces, LEPs, pop up opposite big craters. The antipodal effect is key here. When a meteor hits, it generates P waves, S waves, and surface waves that converge on the opposite side. Models show amplification by factors of 10 or more, enough to fracture crust and trigger melting. On the Moon and Mars, we see this. Big impacts with volcanic features antipodally. Earth's active geology erases evidence, but simulations for Chicxulub show waves disrupting the Deccan area. Even underwater, the impact might have triggered seafloor volcanism, like mid-ocean ridge bursts. But let's be real. Not every impact sparks volcanoes. Small ones just make craters. It takes a monster 10-plus kilometers wide to shake the whole planet. And not all LIPs have obvious impact ties. Many are pure plume jobs. The Yellowstone hotspot, for instance, has been linked speculatively to an ancient impact, but evidence is thin. Critics say correlation isn't causation. Earth's had plenty of impacts and eruptions without links. Still, the hypothesis is gaining traction with better dating and modeling. A 2022 paper explored impact plume interactions, suggesting collisions can seed hotspots by thinning lithosphere. What does this mean for us? It reframes Earth's history as a cosmic pinball game. Mass extinctions aren't just bad luck, they're intertwined with space hazards. It could help predict future risks. Though big impacts are rare, understanding them preps us for volcanic threats. And hey, it sparks wonder, our world scarred by stars, reborn in fire. We've covered the mystery, the evidence, the debates, about 15-20 words of pure fascination. What do you think? Cosmic trigger or cosmic coincidence? Let's geek out more if you want.